Well, now we've got a treat, which is more lighting. This is by Bob Farquhar using LEDs. And Bob, looking forward to this.
All righty. Okay, guys. There we go. Come on here. So I'm not an expert on LEDs, but I want to just share with the people that I met a lot of people that are nervous about doing LEDs or wiring at all. So I thought I'd try to be simplified as much as possible here. So the big thing about LEDs is the current. That's the critical thing that will kill them. The voltage can be adjusted a little bit for brightness and so on. For an example, for this white light down here, for example, if it's a size 5 volts, if you do 5 volts, it'd be really bright light. You can take it down to 4 volts or 3.5 volts. It will still work, be lighter, like a lighter light. So, but for an example, though, if you're going to have a LED that's say 3 volts, and you think, oh, I'll use 2 AA batteries, you will blow the light because the current at that point there's enough current to kill the LED. So that's the main thing to watch the current. So you have to pay attention of the numbers here. So if you're buying some LEDs, make sure the information's on the package or wherever you're getting them from to know what the voltage is and the amperage, the milliamps. Using regulated power supply is the best way to do this. If you do a cheap power supply, and I'll show you a couple pictures shortly, they have a tendency to reverse voltage quite fast, and they can actually blow the LEDs as well. And the other one I'll show you later on here is by wiring your LEDs, the resistors for the LED. Each LED should have its own resistor. I'll show you that why here. So there's the 5 millimeter is a typical one we have when they first came out that we saw. And these other yellow ones here is surface mount. And this is 6 millimeter. And the newer ones out now, they're called 0402, which is 4 millimeter. That's the end of the LEDs right here, the end of this point. This was a little offside here. Some of these, when you buy them, they come with 2 black wires. And if that's the case, the longer wire is the positive. That's something to remember. This one has black and red, so that's okay. So there's cheap power supplies right here. The wall warts, they're not regulated, none of these. So there's some examples. A battery is basically regulated. These are another example here, a step-down regulator. That also has current control in here as well. Or you could use a pulse width modulator. This is adjustable from about 1 volt or half a volt up to 35 volts. So in this example here, there's a sign for the symbol for the resistor. That's a LED. And then generally you see the circuits done this way. V is of course voltage. Now the letter A was already used in something else in that world of the electronics, so they use the letter I for amperage, and they are for resistance. So Ohm's law. So this one here, R is voltage divided by amperage. If you know the voltage, for example, on the LED, you want to know the voltage and the amperage. So what resistor what I'm going to use? That's the one you'd be using, the formula you're going to use the most. So this, for an example here, using a 9-volt battery. I have a white LED in this example, 20 milliamps, and there's 2 volts to run the LED. So what you'll have to do now is find out how much voltage drop, which is 9 volts divided by 2, minus 2 volts, give you 7 volts have to be dropped. So 7 volts divided by 0.020 amps or 20 milliamps is 350 ohm resistor. That's required. And but sometimes you can't find the 350 volt resistor. But in this case, I would go to the 390, even up a 400 or 410 type of thing, rather than going down to the lower number like 335 or something. Just more, is better. Another example, using 12 volts and the same LED. 12 volts might be 2 volts, what is needed for the LED. 10 volts has to be dropped, divided by 20 milliamps, and it's 500 ohm resistor. And you can go up to about 550 or 600 ohm max in that case. The resistor values, these are you see them last time about 4 colors or 5 here, but 3 here with the main ones and then 1 over here. The very last one here is always the tolerance. So generally, like it's a silver gold. Sometimes you get these other colors, but these you don't have. Generally, you want one for gold and silver that you don't need to have exact for us. So this example here, you use a yellow, which is a 4, purple is a 7, black is a 0, so that's 470. And this one here gives you the number zeros, or will be. So in this case, it'd be 3 zeros. So it ends up being 470,000, which is 470 ohm. Their short form is 470 ohms, which implied that the 1,000 is already in there. This other example here, blue is 6, gray is 8, and this 68, and there's the number zeros, that's 2. So it'll be 6800, which is 6.8 thousand ohms is this example. Their gold, of course, is for 5 plus 5 or minus 5% tolerance, and the brown is like plus or minus 1%. You don't have to go that fine in monitoring stuff. So these are examples here of connecting the LEDs in series. So you have the 1 resistor, and for this example, you have 4 LEDs. If one burns out, the circuit is dead. The current, the electricity won't pass through. And you do it in parable. They go, okay, let me use 1 resistor here. There's my 4 LEDs. The problem is you burn that one out. Now the current is going to be higher on the other 3 and going to burn them out. So what you want to do, have 1 resistor for each LED. That's what you want to do. And this is the, if you want more information, this is a good website here. I'll put it on the chat when I finish this one, which is pretty much now. Any questions, anybody? Good. So I'll put them on the chat.
Yeah, hi, Bob. Roy Warner here. Bob, just to let you know that an LED can be run on AC, because what it does is rectifies 1/2 of the sine wave.
Right.
So you want to get half of that on AC as a light. So the only difference is, if you remember, some lights used to flicker if they were on 25 cycles. You
Right.
get the same thing with an LED. If you move your head fast, you'll see the flicker. Otherwise, you won't see the flicker. So you can do it. Just make sure your resistor is big enough to handle the voltage and the current.
The other thing I've used is the double color LED, red and green together. Powered one way is red, powered the other way is green. Put AC on there, red and green goes 6 times a second, makes it light yellow. It's great for signals, a single bulbs signal.
Yeah, it's a good way of doing it.
Yeah.
Well, Bob, thanks so very much. I really appreciate you doing this, and it
Sure.
was really, thank you.
Okay.